Hello, in this video we're looking at learning intention 13, which covers the chain rule, product rule and quotient rule. So these are more advanced techniques for finding derivative functions. We'll start with the product rule. So if you remember, product means multiplying. So it's when you have two functions that are multiplied. I think it's better to start with an example and then give the formula. So the product rule, it looks like, let's say you have the function f of x equals x squared sine of x. And you were told without a calculator to find the derivative of that function. Well, because it's a product of two functions, it's a product of x squared, which is a function, and it's a product of sine of x, which is a function, we can find the derivative using the product rule, because it's two functions, 1, 2, multiplied together. And the product rule works like this. It's the derivative of this times this plus the derivative of this times this. How I think of it mentally, I'm going to write a note of this because I say this mentally in my head every time I do this. I say the diff of that times that and diff of that times that. Now that sounds like absolute nonsense, but I think it'll make more sense when I do this example. So let's find the derivative. It's the diff of that times that. So the derivative of x squared is 2x. The derivative of that times that, so that leaves sine x, so it stays the same, plus the derivative of that times that. So there's a kind of symmetry to it. So the derivative of sine x is cos x times x squared. Let's rewrite it to make it a bit nicer. So that's 2x times sine x plus x squared cos x. That is your derivative function. Let's do another example of the product rule. No, in fact, I'll give you the formal definition. I think you've got it. I'll give you the definition or the formula. I'm going to give you the formula. So the way we write this is if I have some function f of x equals g of x times h of x, well, the derivative is the diff of that, which is g dash of x times that, plus the derivative of that, which is h dash of x times that. So you need to memorize that formula. You need to have that down. If that doesn't work for you, it works for me. Come up with your own way of memorizing this, however that is. I find this works for me, the diff of that times that, so the diff of that times that plus the diff of that times that. If that sounds too ridiculous, come up with your own way to do it. So that's the product rule. Let's do the quotient rule. So I'll clear this. Let's have a look at the quotient rule. So quotient means division. Let's call this example 2, and this is the quotient rule. Quotient means division. So let's look at an example. If I have f of x equals 2x squared over negative the natural log of x. Now this is how I remember it. You don't have to write this down. This is just what I do in my head. I say the diff of the top times the bottom minus the diff of the bottom times the top over the bottom squared. So that's how I remember how to find the derivative when we're doing the quotient rule. And you can see it's two functions being divided by each other. So it's 2x squared being divided by a negative natural log of x, and that's a quotient, so that's a division. So let's follow this this instruction. So it's the diff of the top, so 2x squared, the derivative of that is 4x times the bottom, so times negative natural log of x, minus the diff of the bottom, so the diff of negative natural log x is negative 1 on x, times the top, so times 2x squared, over the bottom all squared. That's your derivative. Let's tidy it up. So take the negative out the front, so negative 4x natural log x. Take as many steps as you like here, but this will become plus 2x because x squared will cancel with an x, and we're minusing a negative which is positive, and that's all divided by, well, that's a negative 1 out the front, so that's going to square to be positive. There are a couple ways to write this bottom part. You could write the natural log of x squared like that. It's sort of uncommon, but it does pop up. Sometimes they might write that bottom part as natural log. They might put the squared there to mean that. So just be aware of that, because it might pop up in multiple choice and you might see that notation. It just means that there. Now let's do the formula. So now that we've seen an example, we can do the formula for this. So if you have f of x equals the quotient of two functions, the derivative equals the diff of that, g dash of x, times the bottom, h of x, minus the diff of the bottom, h dash of x, times the top, all divided by the bottom squared. So you have to memorize that one too. That's how I memorize it. Memorize it how you like. You can come up with your own trick. There's one more thing we have to learn, and that's the chain rule. So the chain rule is I like to think of the chain rule as a kind of cover rule. I'll show you what I mean. It's kind of like nested functions. It's like when a function lives inside of a function. So if you have f of x equals x squared plus 3x minus 5 to the power of 7. Now, if you had to do that with your year 11 knowledge, year 11 you would say, oh, I have to expand all of that, which will be ridiculous, because it will be x squared plus 3x minus 5 in brackets 7 times, group like terms, and then take the derivative. There's actually an easier way, and it's using the chain rule. This is how I think of the chain rule. It's the diff of the inside times the diff of the outside. I'll explain what that means. It's the derivative of the inside stuff multiplied by the derivative of the outside stuff. So imagine covering this part with your hand. So literally like put your fingers on the screen and cover x squared plus 3x minus 5 with your hand, you take the derivative of the outside, pretending that stuff's not there. So the derivative of the outside part, well, you bring the power down and subtract 1 from the power. So the derivative of the outside looks like that. We've taken the power down, we've subtracted 1 from the power. So that's the diff of, oh, I've got this the wrong way around. Diff of the outside times the diff of the inside. Apologies. Let me rub that out if I can find the eraser. So it's the diff of the outside times the diff of the inside. That's a bit confusing. Apologies for that. That is the diff of the outside times the diff of the inside. Alright, so I've got to times it by the diff of the inside. Well, that's 2x plus 3. And that's your answer. The formal kind of way to say it is a bit different to the others. So I'll write the formula, and I'm going to give you another example as well. So the formula, it's saying that a derivative dy dx can be written as a substituted variable, and I wanted to show you this first to show you that it's not that scary, although this looks a bit scarier. A substituted variable. So the way to think of this formula is the du's kind of cancel, and you're left with dy dx, and that dot just means times. So I'll show you how this example would look with the formula, and I'll do it again. I'll do it just here. If you have y equals x squared plus 3x minus 5 to the power of 7, the way they encourage you to do it, and I don't particularly like this way because it obscures the meaning, but is by making a substitution. So replacing the stuff on the inside with the letter u, and then that gets substituted into there, and then you find the derivative with respect to u. So rather than finding the derivative with respect to x, you find dy du, which is 7u to the power of 6. Then you take the derivative of the inside stuff. Well, that's du dx. Then using this formula, you can multiply dy du times du dx. You can multiply these two together to get dy dx. So that's 7u to the power of 6 times 2x plus 3. And then you can substitute u in. And you get the same answer. I checked with as many people as I could. On an exam, this would typically be worth 2 marks. 1 mark for showing you can use the chain rule, another mark for the answer. If you do this and get the right answer, you will get all the marks. So this is showing use of the chain rule. This is slightly longer. Use the method that you feel comfortable with. I much prefer this method. It's kind of like I cover this with my hand, I find the derivative of the outside, then I find the derivative of the inside. This, it adds extra symbols, so you can learn this procedure if you like, but both are fine. So, but you will definitely need to know this formula. You have to know that. So memorize that either way. And if you have been, thank you for watching.